Okay, in this problem on number 19, remember we always want to look for a GCF first. And we have one here because 2 divides into both of them. Both of them have at least one R, and both of them have at least one S. And so that's our GCF. Now we need to put our leftovers in the parentheses and divide this out of both terms. 16 divided by 2 is 8. R to the 4th divided by R1. If you subtract the exponents, you get R cubed. And then you took the S out. Now, let's go to the next term. 2 divided by 2 is 1. I won't write it down. R divided by R is 1. I won't write it down. S to the 4th divided by S is S cubed. Now, that's kind of sloppy, so let me rewrite it. That's 2RS times 8R cubed plus S cubed. Now, this is the sum of two cubes. And when you have two cubes, and you have the sum of them, you factor that by saying A plus B, and then it's A squared minus AB plus B squared. Okay? So I have to think about, well, what am I cubing here? What do you cube to get 8R cubed? To cube 8, to get 8, you cube 2. To get R cubed, you cubed R. So my A here is like 2R, okay, because that's what I cubed to get 8R cubed. And then what do I cube to get S cubed? I cube S. So I write down, just like this says, 2R plus S. And now for the rest of the factors, I have to take the 2R and square it. Well, 2R squared would be 4R squared. Minus, now we got to multiply the 2R and the S together, so that gives us 2RS. And then plus the S squared, because in this case, if you're still confused, A is 2R and B is S. So B squared would be S squared. And that's number 19 factored. Okay, if we look at number 21, I'm not sure if y'all have seen one like this before. I don't even remember if we did one like this. They're trying to get you to notice a pattern here. This would actually be something that might have happened if we did factoring by grouping. And so it's almost like somebody's already done the work for us and we notice, oh, the things in parentheses, they match. So that's like a GCF of both of those terms. Remember, when you have things multiplied, that's all considered one term. So there's really only two terms here, and each term has a y minus 3 in it. Now, what are my leftovers? My leftovers out of the first term is a x, and out of the second term is a plus 2. We'll do one like that. Number 23 is similar. I'll go ahead and just run through it real quick in case you're struggling with it. You got x times y minus 3 plus 2 times 3 minus y. Now, we've talked about this before, but I don't know if you remember. If you have y minus 3 and 3 minus y, they kind of look alike, but not quite, right? Well, here's the deal. You can get them to look exactly alike, and here's how you do it. When you have two things and they're just reversed like this, I'm going to go to the second one, and I'm going to factor out a minus 1 out of both of those terms, okay? If I factor a minus 1 out, that'll be like plus 2 times minus 1 out front. Okay, now 3 divided by minus 1 is minus 3, and negative y divided by negative 1 is plus y. So a lot of people just do all that in their head, but I'm going to show you. I just want to make sure you got why it works. 2 times negative 1, a positive 2 times a negative 1 is a minus 2, and negative 3 plus y I can rewrite as y plus negative 3, which is the same thing as y minus 3. Once I do that, you can see I finally got the y minus 3 by itself. So when you see this kind of pattern, reversed things, subtraction, reverse things with subtraction in them, you can factor out a minus 1 in one of the terms, and I just chose to do it out of that one because I like to have the variable first. And then that, if you factor out the minus 1, all it does, if you look, it changed that plus 2 into a minus 2 because I had the minus 1 pulled out front, and then it just flipped them around like the way I needed it to be. So now, if I'm factoring, my new GCF is this y minus 3 that's in both terms, and my leftovers are x minus 2. And you're done. Now 25 is a factoring by grouping problem that that is not done. I mean, we had some of what we just looked at was some factoring by grouping that had already had some work done to it. In 25, we have PQ minus 2Q plus 2P minus 4, okay? And so we got 4 terms, so what we need to, first of all, let's just check. There's nothing that can combine. There's no like terms here. So if you remember what we do is we say we're going to group these two together and we're going to group these two together and we're going to look for a GCF out of each pair. Well, now both of this, if you look at the first pair, both of them have a Q in it. So I'm going to factor out a Q and the leftovers would be P minus 2. Okay. Now I'm going to go to the second set of numbers, and I notice that a 2, and I'll do that one in blue, a 2 divides out of 2 and 4, and there's no P to divide out because 4 doesn't have anything with it. So, but I can pull a GCF of 2 out, and if I have 2P and I divide out 2, that would be P, and then a minus, and 4 divided by 2 is 2. Okay, now that we see it like this, we go, oh yeah, we got our GCF here. That's what we want to happen to help us factor this. And so this is, the GCF is P minus 2, so we pull it out front and we say, okay, that's our GCF. What are our leftovers? Okay, so our leftovers we write now. You always have to write that GCF down. Some of you tend to forget it, so just be careful not to forget it. My leftovers in the first term is Q, and then I've got a plus and my leftover of 2, and we're done. Hey, so you might be looking at this going, what in the world? I know I kind of, I'm looking at it going, one thing I kind of notice here is that I don't often need to rearrange things, but there are times when maybe I want to, because if you look, if I put these into groups here, neither one of these have a GCF to pull out. Now most of the time you get the GCF to pull out, but the reason it's not here, one of the reasons it's not is they're using 2 different variables. A lot of times we have something else going on where you don't have 2 different variables, so this lesson would, you might not recognize it in this lesson because they do a lot of weird things. So here's what I could do. What if I grouped, what if I could just, this is the same thing as AB plus negative 2 plus negative 2B plus A. And when we're doing all this adding, I changed it to adding just so you could see that it's okay when we're adding to switch the order of things and to switch things around. And so I'm going to regroup some things. I'm going to take this AB and this minus 2B, and I'm going to group them together. So it's AB plus minus 2B. Then I'm going to take this plus A and put it with the plus minus 2 that I rewrote as addition. Now really I could have just written that down as AB minus 2B plus A minus 2. Because of the rule that we can rewrite subtraction as adding a negative, we can really kind of switch this stuff around as long as we keep the sign with it. Now, how did that help me? Well, if I rewrote it, if you look, now if I group it, out of the first pair of terms there that I'm kind of underlining darkly, there's a B that I can pull out. And if I pull a B out, if I divide a B out, I would be left with A and then minus 2. Now, I get to the second part, and there's nothing to divide out, but I notice I have an A minus 2, and I also have an A minus 2 right there. So here's, if you remember, this is what you can do. You can put plus A minus 2 and then just put a 1 out front, because you've got to have some leftovers, and that 1's going to help you rewrite it here in a minute. By the way, I should have equal out in front of every one of these statements, and I can't fit it in now because it's so close to the edge. All right, so I have a GCF of A minus 2, and I can pull it out. And then what are my leftovers? A B plus 1. So I could factor it, but I actually had to rearrange it here. So if you ever have 4 terms and you can't pull anything out like this, try seeing if you could rearrange it and get something to pull out, because every once in a while something like this will happen, though this is the first time I've ever encountered it in my whole life. Okay, so let's look at number 29 next. 29 is a little tricky. It's x squared minus 6x plus 9 minus 4y squared. And if you try to factor by grouping this, there's really not a way even to rearrange it where you could pull anything out and get it to work. So that doesn't work. Now, again, this doesn't happen a whole lot, but it does happen occasionally. If you've tried factoring by grouping and you can't get anything to help happen, and let me just tell you, this is the only time I've encountered this since I saw it in high school in a textbook, so it's not like we even have this happen in a lot of other courses. We're just really learning tricky factoring patterns right now. What if I looked at this and this as two separate terms? What if I kind of group this together and then I group that other term by itself? Let me go ahead and underline it in a different color. I have two perfect squares here. This is actually a difference of two squares factoring pattern. Hopefully we did one like this in class, where I have a squared minus b squared. Remember, I factor it as a plus b, a minus b, or I could put the minus first. It doesn't matter. So you say, where? I don't see it. Well, if you just look at this in isolation, let's say that was all you had on your paper, this is a perfect square because you can square x to get x squared. You can square 3 to get 9. I see there's a subtraction sign, so I could write this down as a minus here and say this is a square. If you think about it, there's the x squared minus 3 squared would be plus 9. And if you remember that perfect square pattern, if you multiply x and negative 3 together, you'd get negative 3x, and then you double it, and there's the middle term. So it does fit that pattern. So here's what I have here. This is really tricky. It's x minus 3 squared minus 4y squared. Okay? Actually, I should have gone ahead and write 4y squared as a square, because I can square 2y to get 4y squared. So in this is my a and this is my b. So if I'm going to do a plus b, a minus b, let me kind of do some color here. I'll do this in blue and I'll do this in a purple color, okay, just so we have some different things going on. So my a is x minus 3, so what I'll do is I'll write it as x, ignore that line. If I get rid of it, it'll ruin the whole video. Let me see. Yeah, it did go away. Good. All right. So a is x minus 3. I put it here. I put it here. My b is 2y. I'll write that in that purple that I said I would write it in. And since it's a difference of two squares, I need one plus and one minus, and it is now factored. Kind of weird, but that's how you do it. All right. If you look at 33, it's another very different kind of factoring thing. We are working on some pretty challenging factoring problems here. I know y'all thought the ones you had in Algebra 1 were bad. Well, these are worse. Okay. Now, here's the thing here. I've got three terms, and there's no GCF, but let's look at something. Isn't this first term a perfect square? It's x squared squared. And isn't this last term a perfect square? It is y squared. And if I multiply these two things together, x squared and y, and then I double it, I would get 2x squared y, which is what is in the middle. The thing about it is I got to tweak it a little bit because I notice there's a minus, and it's a minus 2x squared y. So I can get that by making that a minus. Because if I square a negative, I get a positive. So what is this pattern? This is a perfect square. It is x squared is my first term, minus y squared. And again, you could have written that out as x squared minus y times x squared minus y, but the fast way to write it would just be like this.